I'll record. What if this is useful? So let's first talk about how interest works. We all understand the basic idea behind interest. You give the bank money, the bank does some stuff with the money, and then later on, you have more money, right? So let's imagine, suppose we invest just $1, and that dollar will earn 100% interest because I'm not fucking around. Also, it makes it easier just to not have to worry about factoring out the R. We can reduce the interest down as much as we want. Suppose we're going to invest $1 at 100% interest, compounded. That's the variable that we want to check. We want to see what happens as we change the frequency with which we compound the interest. Now, this is a calculus class, so you should be thinking, I bet this compounding is going to go to infinity. And you would be correct, because this is the thing in calculus class. This is calculus's thing, continuous change. So if you weren't thinking about continuous change and just thinking about compounding continuously, you still have more calculus to study. You got to see what calculus's games are. So, and then we're just going to compound this at various places. Annually. Annually. Are there two L's in annually? Are there two N's in annually? So when I think about this, I'm going to be thinking this 100% once. And then we're just going to increase this. B. Semi-annually. So I'm going to take the 100% and I'm going to do 50% in the first half of the year, 50% in the second half of the year. So 50% twice. Quarterly. 25% 4 times. Monthly. 12%, sorry. 100 doesn't divide by 12, that's fine. 100 over 12. 12 times. I want to see what happens after 1 year. Immediately, this should be a suspicious scheme to you, and clearly I'm doing it to try to make a point, because you recognize that I am breaking up the percentage linearly, but what we're measuring is an exponential function. So if you're like, oh, dude, this seems kind of suspicious, that's because it is, because we're going to be thinking in terms of calculus, and we're going to approximate things by breaking them up. And we just want to know how much is there after 1 year. So more importantly, we want to think about what where the calculation comes from, because we know if something increases by 100%, we're just going to be doubling it. It's going to double it. So if we do this annually after 1 year, 100% growth, $2. So part A, 100% growth means doubling. Here's where being able to answer the question quickly does not help us. Where does that double come from? So when we see the increase by 100%, we know that this is equivalent to multiplying by 2. We know that we read increase by 100% as multiply by 2. We want to think about where that comes from. So there are a few parts. There's the 100% that we start with, that we get to keep. And then there's the extra that we get. So the one that we start with, this is the 100% that we start with, the one that we keep. If nothing changed, we'd multiply by 1. If nothing changed, we multiply by 1. That's what that one represents. Then to this, we're going to add the increase. And the increase is 100%. Percent means per 100. So the plus is increase by 100%. Per is divided by, cent is 100. Increase by 100 for every 100. So this is how we build that multiplying by 2. The reason that we want to break this down into pieces is because we know that increasing by 100% is doubling, even though we don't always know that. Because sometimes they say, you could increase your reading speed by 1,000%. Imagine reading 10 times faster. 1,000% isn't 10 times faster, is it? So they failed their reading competition. That's what happens when you let ChatGPT write your math paper. I've said before, it's entirely appropriate for ChatGPT to get math questions wrong, because if you just ask the most people, they would get the question wrong. So it makes sense because it's trying to emulate humanity. So let's move on to the next one. So this is where we're going to start seeing some exponential stuff show up, and then we can extrapolate from here. So if we have 50% increase twice, the 50% increase, if we want to increase by 50%, that's going to be multiplied by 1.5. So 50% increase, we're going to multiply by 1.5. The reason it's 1.5 is that we have 1 plus 50 per 100. If no increase, it's 1, but we're going to increase by 50 per 100. So a 50% increase is multiplying by 1.5. And we're going to multiply by 1.5 twice. 2.25. And we can see where the increase comes from, because after the first half of the year, we have more. We have a 50% increase on our initial deposit. And then so in the second half of the year, the interest, we're earning interest on interest. So then it's going to result in an extra 25 cents. I will take 1 gallon of premium gas too. No, please, because I have an extra 25 cents. But only like an extra gallon of premium gas. So like 8 gallons of regular and then like 1 gallon of premium. You look at your car because you deserve it. Meanwhile, your car is like, I'm a low compression engine. I don't really care about premium gas. That'd be like serving me like expensive wine. That you're just wasting wine at that point. Just don't pour the bottle in front, or just get the expensive bottle of wine if you want to think, if you want to try to impress me with it, and like pour cheap wine into the expensive bottle of wine, and then serve that to me. I'm like, this is pretty good because it just tastes like red wine. You know, they're like, it's got notes of cherry and oak and I don't know, some kind of alcohol finish. I don't know. It just tastes like wine to me. It's like scotch. Like if you drink scotch, I think you're a liar. If you're like, this is a good scotch. It just tastes like burning and rubbing alcohol. To me, it's a waste. Don't serve me fine scotch. What are we talking about? Oh, yes, premium gas. So now we see what the scheme is going to be. We're going to be, instead of doing, we're going to be decreasing the base, but increasing the exponent. And we know, because we've seen this kind of stuff, that the exponent is going to win. We're decreasing the base, but increasing the exponent, the number of times the factor appears, that's going to win. So notice that our increase here was a plus 25 from the last one, plus 0.25. So we can also predict what's going to happen if we do a 25% increase 4 times. Our base is going to be 1.25, but we're going to do this 4 times. The exponent is the number of times that we do this, and we're just taking that 100% and just dividing it by the number of times. We're splitting it up evenly. 25% increase. That means multiply by 1.25. Start with 1 and increase by 25 per 100. Per 100, just divide by 100. So now I can't raise this to the 4th power. So we're going to break out the calculating machine. So 2.44. So it is an increase, but the amount of increase is less. So if I subtract the 2.25 that we had before, we get an increase of just 19 cents. And then we'll do one more. So now we're going to do an 8.8 increase, but 12 times. So I'm going to take this, divide it by 100, and then add 1. So our multiplier is 1.083. But we're going to do this 12 times. So we can see that the amount of increase is getting smaller. That first doubling the number of compoundings got us an extra 25 cents. And then doubling that again only added another 19 cents on top of that. And then multiplying that by 3 got us another an increase of 17. So only another 17 cents for that 3 times the amount of compounding. So we could see where this is headed, or we could guess where this is headed. So for larger values, let's suppose we take a 1% increase 100 times. So the base is getting a lot smaller, but our exponent is a lot bigger. So here we are, 100% increase per year, compounded at 1% 100 times throughout the year, every 3.65 days. So here we've taken a step from 12 all the way out to 100 and only increased the end result by 9 cents, even going from 12 to 100. And then we could drop that down to 0.1% and do this 1,000 times per year. So just around 3 times per day, your compounding interest, I'll have 1.001 to the 1,000. We would probably round this, since it's dollars, it's going to stop being dollars in a minute, but 2.72. Even though we have 10 times the amount of compoundings, we've only gone up by 2 cents. So it looks like the amount of increase is slowing down. The question is it going to keep slowing down? And we can just think of this in terms of limits, and we can think of it numerically. 1.0001 to the 10,000. And we can think about what's happening as the n increases. And so this is the expression that we're examining. So as you can see, if I've increased by another factor of 10, and we haven't really changed that much. Before we had 2.7169, and I had to go that far because the next one was 2.71826 or 827. So at 10,000 times, let's call that 10 to the 1, 2, 3, 4, 5, 1, 2, 3, 4. And now we're just playing the calculus game. Let's just keep increasing to see if this level's off. Or at least if we can get evidence that this level's off. As we increase by factors of 10, we still see some increase, but it looks like it's leveling off. More digits are locking into place. Now we'll jump up to 1 million. So we'd say 1 million. Oh, I wrote divide by. Sure. Where's my last correct one? Okay. That 1 million? Let's find out. Oh, yeah. There we go. So as n increases, we see this number leveling off. More digits are locking into place. It looks like this 2.71828. It looks like those digits are locked in place. And as we go up, it looks like we're approaching something. So we're interested in what happens as n goes to infinity. And that's when we get to E. And E is just 18281828, which is unfortunate that our calculator has this number of digits because that makes everybody think that this is a rational number that has a repeating 1828. Questions? Now, this is an infinite number of compoundings per year. So this is where we're thinking of compounding continuously. We refer to this as continuous compounding. So rather than that discretely compounding the interest millions of times per year, we just model it with continuous compounding. And this will be our, just imagining that we are always compounding. We're compounding an infinite number of times per year. Now, if we wanted a different rate to show up, Our new rates just show up. That 1 was the percent that we had an increase. So we took 100 per number of times per year. So if we have a different rate, that'll just show up as the numerator. Oops. And go. So our multiplier would just be e to the r. So if we had a different value of r, if r was something more reasonable like 10%, then it'd be e to the 0.1. So for example, so if we're increasing by 10% compounded continuously, this would be an effective rate of 10.5% compounded annually. So 10% continuous compounding is equal to, just grab this part right here, 10.5% increase per year. Take the 1 off the front. That's the 100 that we start with. That's if we do nothing. Multiplying by 1 does nothing. 1 is the multiplicative identity. Questions? How's everybody okay? This is from a series of things I like to point out. It's like, well, you're too old to not start saving for the future. Saving for your future should happen as soon as your signature becomes legal. Any questions? Comments? Snyder more? Fucking perfect time. How's everybody okay? Everybody looks so very sad. Is it because I brought up the future? You know, we're young people and it's 2023. We don't have to think about the future. And specifically, we're mad at you and your generation. Like, well, that's fair. 100% fair. Know this, your children are going to be mad at you for fucking up their future. If we even get that far. I mean, let's be real. I'm just kidding. Grandchildren, I'm just kidding. I've said it before. Of all the generations of humans, I believe in young people today. And young people today, I've said this before, and this is not just pandering. It's not like I'm making money off ticket sales or some shit. So it's not just pandering. I do believe that young people today have a chance to be the greatest generation of humans that have ever lived, because if there are future generations, they will have these young people today to thank for it. Because generations before your generation have spent all of our time making things worse for you. And now we have enough communication where you can see how bad we have made it. And hopefully you can seize the reins of power from us olds and start making things better. You have a chance to save the world is what I'm saying. And that could make this generation the greatest generation that's ever lived. Because they could literally save the world because we are literally facing an existential crisis. Now, if it doesn't work out and humanity winks out on your watch, know that I will not hold any of you to blame for that. I'll just say, sorry, dude, we kind of fucked that up for you. We gave you a very difficult problem to solve. So no blame, that's on us. Any questions? Since I'm a Gen Xer, I'm specifically going to blame the boomers because that's just what generations do. You just go for the one that's right before you. Right? Funny, I saw a TikTok where a guy's like, oh, hey, who let Gen X off the hook? And then it's followed up by a bunch of Gen Xers trying to defend Gen X. And the defense is essentially, we didn't do shit. We didn't do anything. And all I can say, as a Gen Xer, that's the fucking problem. We didn't do anything. We said, man, this sucks. And then walked off. So, yeah. Anyway, that's going to do it for today. This is me giving hope to the future. I'm telling you to invest in your future now because I believe there will be one, because I believe that you're going to save humanity. So go out there, save humanity. Be mad about us. Be mad at us all you want. We deserve it. That's it for today. I'll see you all on tomorrow, if there is a tomorrow. Have a good day, and thanks for playing.